In the previous class, we learned about combination reactions. In that combination reactions, mostly heat is involved. The reactions in which heat is released along with the products are called exothermic reactions. The first combination reaction was when water is added to quicklime, slacked lime is formed along with a large amount of heat. So that is an exothermic reaction. Which one? When water is added to quicklime, water reacts vigorously with quicklime, forms slacked lime. What is slacked lime? Calcium hydroxide. And large amount of heat is evolved. So that is an example of exothermic reaction. Another example is when natural gas is burning. In our home we are using natural gas for cooking. Natural gas, what is the main component? Methane, the simplest hydrocarbon, CH4. That reacts with oxygen, forms carbon dioxide and water, and large amount of heat is evolved. Then third one, exothermic reaction that is occurring in our body, that is respiration. We know to get energy, we get energy from what? The food we use, eating. This food we eaten, that is broken down into glucose. Mostly we are taking to get energy. Which food we are eating? Carbohydrates. We are taking in carbohydrates. This carbohydrate during digestion converts into glucose. This glucose reaches to the cells of our body and reacts with oxygen, and it is converted into oxidized carbon dioxide and water, and energy is released. During this process also, feeble amount of heat is evolved. We can't feel it, but evolving. So respiration is also we can call as exothermic. What is happening? When glucose reacts with oxygen present in the cells of our body, it converts into glucose is broken down into carbon dioxide, water, and energy is released. And so this is also an exothermic process. And the fourth one, which one it is? That is, we can get compost. You have learned about how to produce compost from the wastage. You have learned already in 9th standard. In that one also, the vegetable waste, from vegetable waste, that is decomposes to produce compost. That is also an example of exothermic. There also heat is evolving, so that are also. So we learned exothermic thermic reactions. Which are the exothermic reaction? I am also once more explaining. First, when water is adding to calcium chloride, produces calcium hydroxide plus heat. So this is a first example of exothermic reactions. Exothermic reactions. Second one, which one? Burning of. Second, which one? Burning of natural gas. Burning of natural gas. In burning of natural gas, what is main component of natural gas? Methane, CH4. That react with the oxygen, produces carbon dioxide and water. So CH4 here, 2H2O. So now total 4 oxygen, so 2O2. Plus heat is produced here also. So that is also an example of a exothermic reaction. Third example is what? Respiration. Respiration. In that one, what? Glucose. What is formula of glucose? C6H12O6. That reacts with the oxygen. Gives carbon dioxide plus water plus energy. We are getting energy means in form of heat. So C6. 6 carbons are there, 6 CO2. 12 hydrogen, so 6 H2O. Now 6 O2, 6 hydrogen. So total here 6, here 2 6 are 12 plus 18, here 6. So total 6 O2. 6 H12 O6 plus 6 O2 gives 6 CO2 plus 6 H2O. And fourth example for that one is what? Decomposition of vegetable waste. Vegetable waste to form compost. So understood now? So what are exothermic reaction? The reactions in which heat is released along with the products. Examples are this quicklime react with water, calcium hydroxide is line. We learned one only. Natural gas, methane is a gas, oxygen also. I am not written the symbols. Without writing symbols also you can write. And then respiration, that is glucose react with oxygen present in the cells of our body and converting into broken down into get energy along with carbon dioxide and water. Then decomposition of vegetable waste to form compost. These are all in this one. Here only combination reaction only. These are all natural exothermic reaction in which energy is releasing heat. Now next one, that is decomposition reaction. Next question, decomposition. In decomposition reaction, that is opposite to combination reaction. In combination reactions, 2 or more reactants combine to form a product. Then in decomposition water, from single reactant we are getting, if we are getting 2 or more products, that is called decomposition reaction. In decomposition, in order to occur decomposition reaction, mostly energy we have to supply. So mostly these decomposition reactions are endothermic also. Endothermic. Here for first in activity first 1.4, take 2 gram of ferrous sulfate in a watch glass or in china dish. You can take ferrous sulfate. What is the color of ferrous sulfate crystals? That is like green in color. Now heat it. Then it decomposes. Its color will change and decompose to produce ferric oxide, Fe2O3, along with sulfur dioxide and sulfur trioxide gases. So ferrous sulfate on heating gives ferric oxide, brownish black in color ferric oxide, and sulfur dioxide and sulfur trioxide. Sulfur dioxide and sulfur trioxide means when crackers are burning, we are getting one special type of smell. That cracker smell only here on heating we are getting sulfur dioxide. Now next one, it is decomposition of calcium carbonate. What is calcium carbonate? CaCO3. When calcium carbonate is heated, it decomposes to give calcium oxide. What is calcium oxide? To clay and water. That is the decomposition. Here also heat is used. Another one, it is lead nitrate. Take lead nitrate in a boiling tube and heat it over a flame. Then it will decompose to produce lead oxide, PbO, and nitrogen dioxide, and oxygen will come out. These are examples of what? Examples of decomposition reaction. In these all, heat is used, means for decomposition. So these all these reactions which were now explained, they are also called thermal decomposition. Thermal means energy is used in the form of heat. So now I am showing that reaction, how it is. So now ferrous sulfate, FeSO4. ferrous sulfate. That on heating, then the is shown by, gives Fe2O3 plus sulfur dioxide SO2 plus SO3. So 2 FeSO4, SO2 plus SO3, total 8 oxygen. 3 plus 2 5 plus 3 8. Sulfur 2, 2 sulfur, 2 iron. So balanced equation. Ferrous sulfate, what is the color? Green. And this is brownish black. So this is one of first step of heat. Here heat is used. So this one is an endothermic reaction. Next example is what? First is this one. Second, calcium sulfate, calcium carbonate, calcium carbonate on heating. Calcium carbonate on heating gives calcium oxide, means take a piece of calcium carbonate, then using pair of tongs you heat it over a burner, then it will decompose to give calcium oxide, white powder, quicklime, and a carbon dioxide gas. This is quicklime. This is calcium carbonate. Understood? No, actually ferrous sulfate is correct formula is FeSO4 7H2O. So while heating, that water crystallization is losing. That's why its green color is changing into brownish black, forming ferric oxide actually. But while writing equations, we are not using that is 7H2O in the formula. Actual formula is FeSO4 7H2O. In this way writing. So when heats, this water of crystallization is lost and forming ferric oxide. But while writing reaction, balanced equation, we have to write for ferrous sulfate only FeSO4. Generally we are writing only FeSO4. So 2 FeSO4 plus Fe2. Now calcium carbonate. Now one more example I given, that is what? Lead nitrate, PbNO3 twice. That on heating gives PbO, lead oxide, plus nitrogen dioxide, NO2, plus oxygen. So 2 PbNO3 twice gives 2 PbO. 2 2's are here nitrogen 2, here also 2. 2 2's are 4. 4 NO2 plus O2. So now look, 2 oxygen here, here 8. So 10, 10 plus 2, 12. 3 2's are 6, 6 2's are 12. So balance. So this is the balance equation. This fume, nitrogen dioxide, is brown fumes it is. They are pungent. Pungent, you know what is meant by pungent? When chili powder is on heating, what tastes smelling? Feels suffocation. That is pungent. So here is nitrogen dioxide also coming out as pungent smell only. Nitrogen fumes, brownish color fumes are coming out if lead nitrate. These all reactions, here also heating only. These all reactions, energy is used in the form of heat. So they are called thermal decomposition. What is it here? Thermal decomposition. So these are all examples of what? Thermal decomposition also. Lead sulfate on heating, calcium carbonate, lead nitrate on decomposition, that all used energy in the form of heat. So they are all also called thermal decomposition. Here heat is used. Now next one, decomposition reaction of water. Decomposition reaction of water. Water, how can we decompose water? Simply by heating we can't produce. That we are doing at home, or water is boiling, then water is not decomposed to get hydrogen and oxygen. Only water is converting into, liquid water is converting into gaseous form only. So that not only simply by heating we cannot decompose water. Here energy is used in the form of electricity. For that one, take a plastic mug. Plastic mug. Then drill holes at the base of a plastic bulb. Drill holes. Then fit rubber stoppers. They are fit rubber stoppers. So this plastic bulb rubber stopper is rubber stoppers. Then insert carbon electrode. Insert carbon electrode through this rubber. Now connect these carbon electrodes. So these are carbon electrodes. Both are carbon electrodes only. This one connected to a battery through a switch. Key we are learning. Switch means key only. To 6-volt battery. 6-volt battery. Now pour water into this mug in such a way that the electrode should be, these should be immersed in it. That should be immersed. Means these electrodes should be immersed in that one. Now take 2 test tubes that is filled with water and invert them over these electrodes. So take 2 test tubes. Test tube filled with water and invert them over these electrodes. Now switch on the battery. In this water you have to add a little sulfuric acid also. Why we are adding dilute sulfuric acid? We know water is actually, it is a non-conductor of electricity. Tap water is little conducting. So to make it a good conductor of electricity, we have to add a dilute sulfuric, few drops of dilute sulfuric acid you have to add to water. Then switch on the battery. Then keep it, this one apparatus keep undisturbed for some time. Then after some time you can see that bubbles are coming this one. Bubbles are coming out in this one. Here this electrode is anode and this one is cathode. Bubbles are coming out and these bubbles will displace water. Actually these test tubes are filled with water. As gases is forming, gases are forming, that will displace the water downwards and we will get here to this, here water, here gas, it's a double volume here gas. In this way we will get it. In anode we are getting oxygen gas and in cathode we will get hydrogen gas. Now after, when the reaction is over, take this gas, test tubes containing gases, then bring a lighted matchstick over this. Hydrogen gas will burn with popping sounds. Means we know hydrogen is a highly combustible gas. So it's, and here into this one, if you are bringing lighted matchstick, it will burn brightly. We know oxygen is a supporter of combustion, so burns. Here it is forming, reaction is happening, proper reaction, and a popping sound is forming due to the presence of hydrogen gas. So here what, first take a plastic mug you have to take. Then at the base you have to drill 2 holes. Then fit that holes with a rubber stopper. Then through this rubber stopper insert carbon electrodes. These carbon electrodes are connected to a 6-volt battery through a switch. 6-volt battery. This one here, this anode, this is cathode. Then to this pour water to this mug such a way that electrodes should be immersed in it. Electrodes should be immersed in it. Then take two test tubes filled with water and invert them over these electrodes. Then switch on the battery. Switch on this battery. Then keep it undisturbed. This apparatus undisturbed for few minutes. You have to keep it like that. Then you can see bubbles are coming in these electrodes. Bubbles. These bubbles means gases. Gas coming that will displace the water downwards. Actually, these test tubes were filled with water. As gases is forming, this water will be displaced downwards. And after some time, you can get gases. The gas that is we are getting in anode is oxygen, and that is in the cathode it is hydrogen gas. And the volume of gas also, look, here difference is there. Hydrogen gas, the volume of hydrogen gas obtained is double than the volume of oxygen gas. What will be the reason why it is? We know that water is what? H2O. Means two atoms of hydrogen combined with one atom of oxygen. So for one atom of oxygen, two atoms of hydrogen were there. So if your volume also like that only. If how much oxygen is there, it's a double. Means H2O, water H2O. So one atom for that one, two hydrogen. Means how many oxygen atoms are? It's a double is hydrogen. So if you are getting how much volume of oxygen is getting, it's a double, you will get it as hydrogen. So from this experiment we can conclude that the hydrogen and oxygen, the ratio of hydrogen and oxygen, the ratio of hydrogen and oxygen present in water is 2:1. So this is an activity that proves that hydrogen and oxygen present in that one in the ratio 2:1. So this is a decomposition. Electrolysis. What is this? Electrolysis of water. Electrolysis of water. So here decomposition is taking place. Decomposition taken place. With the help of water, with the help of electricity. So here in this decomposition, energy is supplied in the form of electricity. Now another example for decomposition. That energy is used in another way. The experiment now I explained electrolysis of water is important. You have to study well that one, and its diagram also, that label diagram you have to draw. Now next to decomposition, here decomposition reaction with the help of light it is. Third one, using light. Take silver chloride in a watch glass. Silver chloride. What is the color of silver chloride? That is white powder. White in color. Silver chloride. That kept open in sunlight. Then after some time you will obtain its color will change to get silver. What is the color of silver? Grey. Plus chlorine gas is evolved. So 2AgCl gives 2Ag plus Cl. So this is the balanced equation. So here this is also a decomposition reaction only. Here energy is used in the form of light. Sunlight it is. Light it is used. 2AgCl gives 2Ag plus Cl. So a silver chloride, its color first was taken white powder to us. Then after some time, if it is kept open in sunlight, it will turns into grey. Grey color one, it is what is silver, metal. Chlorine gas will be evolved out. And in another one, light is a decomposition reaction in light, it is silver bromide. Silver bromide means this is the chemical used in black and white photography. Black and white. In early time times photos are in black and white photos. In that one, films using there it is covered with silver bromide. That chemical is silver bromide. That also on light film Ag silver plus bromine. So 2 AgBr sunlight. Sunlight or light, any light. 2 Ag. So this decomposition reaction where it is used, this is an example for what? Where black and white photography. Black and white photography. So these are all examples of decomposition reactions. In the what is decomposition reaction? If a single substance is converted into two or more products with the help of energy. Here in all this one energy is used. So these all reactions are endothermic reaction. Exothermic reaction in combination reaction we said their heat is released. Here energy is used. First we learned where in decomposition reaction where heat is used, that are called what? Thermal decomposition. Second one we learned in electricity used decomposition, that is what? Electrolytic decomposition. Third light is using, so that is photolytic. Photolytic decomposition. Photolytic. So this one can be asked, what is decomposition reaction? Which types of energy is used? Give examples, write examples for these energy used one. So first for heat, then for by electricity, then by sunlight or light, simple light. In photographies, olden times photos are taking by using these reactions. So black and white. These are all about decomposition reactions. Then in that one, page number 10, questions, few questions written. In that one, a solution of X is a solution of a substance X is used for whitewashing. Name the substance X and write its formula. For whitewashing, which substance? A solution of a substance X is used. Which one solution is used? Slaked lime solution. Actually, it was what? Calcium quicklime. To that one, water is added. So, what is the substance X? It is quicklime. Write the reaction of the substance X named in one above with the water. That also he written in combination reaction also written. I explained in that one, and in exothermic reaction also written. What is the formula? What is the equation? Calcium oxide CaO plus H2O gives CaOH twice. Now second question is, what is the amount of gas collected in one of the test tube in the activity? Double the amount collected in the other and name the gas. In electrolysis of water we see, while electrolysis we got at anode oxygen and at cathode hydrogen. Here the volume of hydrogen obtained is double that of oxygen. That is because water is formed by combination of hydrogen and oxygen only. There one atom of hydrogen combined with two atoms of hydrogen. Otherwise, one molecule of oxygen react with two molecules of hydrogen to produce two molecules of water. So, how much oxygen is used? It's a double hydrogens are combining to produce water. That's why while decomposition we are getting double the volume of hydrogen than that of oxygen. Now, next one it is displacement reaction. It is what? A displacement. What is meant by displacement? So we now learned two types of chemical reactions. One combination reaction. The next word decomposition reactions. Now third one it is displacement reaction. Displacement. Displacement reactions. Short form of reaction like this right here. When a reactive metal, when a more reactive metal, when a metal is kept in a solution of another metal, if it displaces, here more reactive metal only displace less reactive metal, that type reaction is called displacement reaction. So when a more reactive metal placed in a solution short form of solution with this writing, in a solution of less reactive metal, then this more reactive metal will displace less reactive metal from that solution. This is called displacement reaction. For that one, we can do this one. Take two test tubes containing copper sulfate solution. Copper sulfate, two test tubes containing water, copper sulfate. In both, take a copper sulfate solution. What's the color? Blue. Both of us was blue. Now take iron nails. Iron nail you are knowing. That one you have to place in this copper sulfate solution. In this one, iron nail. Iron nail here. Here no iron nail, only copper sulfate solution. Keep it like that only. After some time you have to check. Then we can see this iron nail that is kept immersed in copper sulfate. It will have brownish color. Means, and the color of copper sulfate was first was blue. Now it start to fade, blue color, and its color become light green in color. Light green. Blue changed into light green. This copper sulfate is to understand the color change only. It was blue only. Now iron nail is kept inside. Then after some time, while observing that iron nail's outer covering was covered with brownish color. Brownish color means copper metal gets displaced from this copper, and in that place iron came. That is like this. Fe, iron metal, that is added to copper sulfate solution, CuSO4 aqueous, gives FeSO4 aqueous plus copper. So this is the reaction. This is the displacement. Here iron is more reactive than copper. So less reactive metal is what? Copper. Its salt solution is copper sulfate. To that one we place the iron. Then this iron will displace copper from its solution. Means from copper sulfate, copper is gets removed, and in that place iron is coming. So we get this is displacement reaction. Another example, it is zinc also. Zinc, second. This is the first example. Second, zinc metal. That is also reactive metal than copper sulfate. CuSO4 aqueous gives ZnSO4 zinc sulfate solution plus what is the copper. Zinc sulfate plus copper. Another one example is lead, Pb. Reactive with the copper chloride, CuCl2, gives PbCl2 plus copper. This is also a solution only. Yes. These are examples for displacement reaction. So, in displacement reaction, when a reactive metal is placed in a salt solution of a less reactive metal, then that more reactive metal will displace the less reactive metal from its solution. That is called a displacement reaction. Examples are given here. Now, double displacement reaction. In any reaction that produces a precipitate, means here groups of atoms are displacing each other. Groups of atoms are displacing. That type reactions are called double displacement reaction. For that one, take a solution of sodium sulfate in one test tube, Na2SO4. one, add sodium sulfate, barium chloride solution. BaCl2 aqueous. Barium chloride solution. Then we will get a precipitate of barium sulfate sodium plus sodium chloride 2NaCl. So look here, with the sodium it was sulfate, and with barium here chlorine. Now with the sodium this chlorine. So look, chlorine from barium chloride changed it to in the place of sodium, and barium, chlorine, barium, and here the sodium and sulfate. The barium replaced in the with the sodium is replaced by barium, so barium sulfate. This double. So when group of atoms or ions are displaced each other, only changes its places, that is called double displacement reaction. Example, when to aqueous solution, take in a test tube sodium sulfate solution, to that one same amount of barium chloride solution you have to add. Then we will get a insoluble precipitate of barium sulfate and sodium chloride. Sodium chloride here aqueous solution only. So this step reaction is also called precipitation reaction. Precipitation means insoluble solid is formed. This is example for double displacement reactions. Now these all you have to learn thoroughly. Equations also balanced one. Then if any doubts coming, you have to WhatsApp me. And always after watching the video, you have to give the feedback how it is done and it is followed or not. Understood?